Welcome to DB Workshop channel. If you haven't subscribed to this channel, requesting you to please subscribe. Today we will discuss few points about Unix Linux operating system. The topics: Linux operating system, components, few important points, and few Linux commands. Let's start. The first thing, we would like to compare between Linux operating system and Windows operating system. So the point is, Linux is free of cost, where Windows is expensive. Linux have a open source code. Source code is available, whereas Windows don't have a source code available. It is not freely available. So Linux is more secure, it is more efficient, it is customizable, and the file system, it has like ext2, ext3, ext4, this kind of file system it could have, and file names are case sensitive, whereas in Windows it is vulnerable to the virus or malware attacks. It is less efficient as compared to the Linux. Windows is less efficient, and Windows is not very much not customizable, and it has a file system like FAT and NTFS, this kind of a file system it have, and file names are case insensitive. The next point is components of Linux operating system. So kernel is a core part of the operating system in a Linux. It does all the major activities. Kernel interact directly with the hardware. It hides the low level hardware details. That means abstraction from the system or application programs. How it can do that? So it can achieve these goals. Kernel has a system library. System library is nothing but this is a set of the special programs or the functions. So these programs and functions provide the kernel features to implement the most of the functionality of the operating system will be done by these special kind of the functions or the programs that has been included in the system library. In turn, it helps the programmer utilities. Any program or any utility can use the kernel features without having a direct access into the kernel. For example, it can call a kernel function, but it won't have access to call the kernel function or call the kernel feature. How that is possible? What happens? Every program or utility would have access to the system library, and that system library would have a special function of the programs having access to the kernel area. So program or utility will call the system library, and this system library would have access to the kernel. So that's why it can call the stuff that it won't have even access to. So using the system library, it can do the stuff that it won't have even access to. So system library is used by each and every or most of the application programs, and it is used by user utilities. So in turn, it would help for application program or user utility to communicate with the hardware. Components of Linux operating system. What is system utilities? System utilities are the set of the special programs which does the individual level tasks. If we talk about the architecture of the Linux operating system, first thing is the hardware layer, where we have all the hardware. Second thing is kernel. Kernel is a core component that directly interact with the hardware. Third thing is a cell. Cell is the interface to the kernel. It hides all the complexity of the kernels from the users, and it takes the command from the user and does whatever the command is meant to do. And utilities just users are provide few utilities to run, and these utilities just to provide the functionality. Most of the functionality of the operating system is done by utility programs. Again, few more points. For example, named pipe is something that kind of a pipe. It works on a sequentially order from it takes input and process it sequentially and gives output. So these are the named pipe. It cannot allow the random access, whereas the regular file can allow the random access. If we are talking about a named pipe, we are talking about a named pipe in a Linux or Unix, whereas a regular file in a Linux and Unix can do a random access. Kernel IO subsystem, it is just used for IO scheduling. Device driver, the function of a device driver are just doing the data transfer. We already know interrupt handler is something that allows to do the IO request. We already discussed what are the interrupts. So interrupts is something that there are two ways, just polling or interrupting the CPU. If CPU is doing something and it just keep on polling each and every hardware device and see if there are some requests are coming for CPU. CPU suspend its own task and try to serve those requests, and once that request is fulfilled, then it goes to the next test and next task. Whereas in the interrupt has its own priority. So if CPU is doing something and if you press a keyboard button, so keyboard button would have a more priority than whatever the CPU is doing. So what happens, that CPU will suspend its own task and try to do whatever the function is required or whatever the interrupt is coming from the keyboard command, because that would have linked to the IRQ interrupt request line, and that will help the CPU to process that request. Once that is completed, it goes on to the its previous task, whatever it was doing earlier. Again, the device controller get the information from the controller register and put it in the data buffer. So that is the task of the device controller get the information from the controller register and put it in the data buffer. One command, what is grep minus I, and some text string and then name of the file. So grep is a search engine. So for example, if you give some text string, some string, so that string would be intended to search in the file name. Minus I tells it is case insensitive. So whatever the string we have written over here, for example, we have written the text underscore string, it will try to search it in the file, and name of the file is file name text. So it will try to search that string, and making it case insensitive means if even if it have not an exact match, but it is just different in a case, then also it will just report it. So making the search case insensitive, you have to use minus I flag. Next one is cut minus T, and this is delimiter, and minus F1 means the field number, so it is the first field. So it is saying that you just read this file name.txt and assume that delimiter is this pipe, and then just print the first field, that means first column based on this delimiter. Next one is grep minus A, and then some text string and then name of the file. So that means if it is a capital A means the word would be, if it is a capital A, it could be a small a also. If it is a small a, then it could be a sequence of the numbers, sequence of strings, sequence of special characters. That would be considered as a word. Otherwise, if it is a capital A, then complete. It is the delimiter is a space. For example, if I have IP address, if I say IP address is 127.0.0.1, so that comes out to be complete word if it is a capital A. Otherwise, if it is a small a, that means 127 is a one word, dot is a second, and 0 is a third. So that means the sequence of the numbers is a one word, sequence of special characters is a one word, sequence of characters is a one word, and digit is another word. So that means grep minus A is telling about, you just look for this word and you just try to see what is the line after this word if it is found. Minus B means before. What is the line before you have found the word? Minus C means it will print both line before and line next. It is very helpful. For example, if you are searching for some log file and you see the error message, it would be great for you to just extract the lines before the error coming and after the error coming, so that you could have a more insights about the error is coming in the log file. So it is very handy when you use these grep commands based on your requirement. The cat is just it is used in pipe to move the standard input to the standard output. T is also similar to cat. So it is cat means concatenation simply sometimes to just print the file. So it is just it make the uses of the pipes. It moves the standard input to the standard output. COWM it is used for comparing. It is used for comparing the files. Grep -v is just about to searching this text string in this file, but the point is -v is telling it is a reverse toggle. I mean, it just won't show the lines having this text string is found. Otherwise, all the lines having this text string is present will not be shown, and everything else having this text is absent will be shown. Standard in and standard out. Linux filter standard in and standard in is a standard input, standard out is a standard output. SED is a stream editor, editing the file content in the display, so it won't do the change to the original file. So whatever change is requested, it is just it can search, it can replace, it can delete, it can use a regular expressions. So set is a command that can be very helpful if you want to edit some kind of a file or some kind of a file, so that it could do these operations. It can do the search, it can do the replace, it can do the delete operation based upon a regular expression. Let's see the example to have more clarity about it. For example, set and then S means we have to start with a single quote and goes with the ending single quote. So whatever in between is a command for this SED, that means a stream editor. S means search, and this is separator. So S means search for ABC text and replace it with the XYZ /G tells do it globally in the complete file, and this is the name of the file. So that means this command will ask SET to search the ABC string in this file name and replace it with XYZ. Z means globally in the file. In the complete file we have to do it. Again, grep -v, it is if it is a small v, it will just search for this string in the file, and -b means before, and -b if it is small, that means it is asking about searching the word. That means a small word. In a small case word is written. So if I'm saying it is a small case, that means the sequence of the letters or digit or underscore. For example, if I'm saying 127.0.0.1, that means it has 7 words. That means 127 is complete word, and then dot is a one word, 0 is a one word, because this is a sequence of digit. Again, this is a sequence of digit, and this is sequence of special character. So that means decimal is also a character, so it is a one word. If I'm talking about a chapter word means they are separated by a byte space. For example, if I'm saying 127.0.0.1, and then there is a space in front of it or end of it, so this comes out to be has one word only. So based on this criteria, it will try to search. If capital B is written over here, so text string, whatever the text string is written over here, it will try to search the text before the string, and it also search for the text before the word. So only difference is how we interpret the word. -c, it will just search for this text string before the file and after the file. Both lines will be printed. So grep -b text string and this file name, that means it will search for the text string in this file, and before line, whatever the line before the where search is found will be printed over the screen. Display the line before the word that is found. Or simply we could say that text string is just a string of the text, and it will just keep on searching it. If it is found, the line before the word will be printed over there. The points to remember: these are very simple commands. WC is a word counter. WC -L will tell number of the lines in the files. -W tells number of words in the file. Number of C tells number of characters in the file. OD means octal dump. TR means a translate. For example, if this is a file name, and if I'm saying TR, whatever, I'm just trying to print the text of this file, and that will redirect it to the pipe. So whatever the content of the file name _txt will be pipe will be sent as an input to the TR. TR will translate, and it is telling that from the lowercase A to Z means from A to Z any character, and number of times it could repeat. So every lowercase word or character, every lowercase character will be mapped to uppercase character. So this will tell just converting the lowercase characters in the file to the uppercase character. Unique is just filters the duplicate adjacent lines in a file. So it would be helpful if you have a sorted file, or maybe you don't want to have a repeated lines, adjacent repeated lines. Awk is one of the most prominent text processing utility. So again, if you want to process a text, you could use awk. For example, this example written over here, if you see AWK and single quote, and it is saying that starting curly bracket and ending curly bracket, and then single quote is ending over here, it is telling that print $3. $3 is telling that the third field over there. So because I'm not talking about the delimiter, so that means by default the space is a delimiter. So if I'm seeing this as a file, so first column is this 1 2 3 4, second column is the name of the student, third column is the name of the subject, and fourth column is name of and fourth column is marks. So $3 is telling, okay, print the third column. Third column means this one, name of the subject, and then /t. /t is just a tab, so it is telling, okay, print the tab after you print the column name. And then $4 is telling fourth column, so that fourth column will be written over here. So awk is a text processing utility if you want to do some manipulation or just doing some calculation over here, and based upon, you could have different things. It is very powerful, and text processing in the engine, it has hundreds of millions of functionality can be done using this, so we could do that. Next one is a find. Find is a command if you want to find some file. So for example, find -name and name of the file. So it will tell us, okay, find, and then we could for example, find is a command. Find commands tell whatever the path we are written over here. It could be a dot, or it could be a slash, or whatever the path we want to search. We can tell that, okay, go to this path and try to search. Find means a search. -name means whatever the name of the files you want to search, and -p means print the output. The fork is a Unix operating system, and it has a it will just create a new process itself. So for example, see this example, int a and equal to fork. Fork means if a equal to 0, a will be written as a 0 for the child process. It will create a new process over there. So and for that process it will return the 0 for a child process. So a will be assigned 0 for a child process, whereas a won't be equal to 0 for a parent process. brk just change the location of the program break defined at the end of the process data segment. Wait is a built-in command for Linux to do the wait between competing running processes. So that is simple to analyze. Kill is just a command to just using process ID -9 is about to kill. Tar is stand for tape archive. It is used for compressing or just keeping the tarball or just creating the backup. So tar can be used to just have the collection of the files and retaining its directory positions also. So it just compress it. We could just create a tar file, compress everything, and then uncompress it. There is a difference between xargs and exec. For example, here -exec is telling that you have to run this command, whatever this command is doing. It will just send each and every, the output of this command will be sent to the exec tool, and exec will do the ls means it will just simply list. If I say rm, it will just delete those files. Whatever the output is coming, it will just run the delete command on that output. ls means it will just run the ls command, whatever the output is coming from here. Next we will discuss the find command. Find command is used to find the files recursively, whatever the path we provide. So if we provide the path over here, if we provide a dot over here, that means in the current directory. If we provide a slash, that means a root directory, or whatever the path we want to provide, we can provide it here. We have other arguments like -type, what kind of a file it is, or so many different parameters we could have. The simplest parameter is -name, that means the name of the files we want to search, and -print. -print means the output will be printed over the screen. Fork is a operation where process just created its own copy. For example, if I say int a and equal to fork means it will create a the process, whatever the process it is running, it will create its own copy. So the child process would have a return type of this fork function would return a 0. So that means a have a value 0 for the child process. It would be a copy of the process itself, and a is not equal to 0 if it is a parent process. Break, it is just about to change the location of the program. Break, generally we say that it is just end of the process data segment. Wait is about wait for the other running processes to get completed. So used with the process ID or job ID. Process ID of the, as below that, process ID of the last command of the current cell. So right now we will discuss a few commands. Find command is used to search the file in the Linux. For example, the syntax is find, and then the path. If we say the dot in a path, that means it will search in a current directory. If we provide a slash, it will search in a root directory. And or we could provide a path over here. -name is a switch that will tell us what will be the name of the file that need to be searched, and -print will, it will print the output on the screen. Fork is a operation that a process create a copy of itself. So that means if I say int a equal to fork, that means the current program will create its own other copy, and the child process will be created, and child process will return, the fork will return a as a 0. A will be equal to 0 if it is a child process. If it is not a 0, that means a parent process. So fork will be just create a copy of the process itself. brk is used to change the location of the program break. brk command is used to change the location of the program break. Generally we define it as the end of the process data segment. So wait is waiting for the current process to get completed used with the particular process ID or job ID. Process ID of the last command will be known by the current cell, so the wait will be applied to the last command. If no process ID or job ID is given with the wait command, then it will wait for all the child processes to get completed. Okay, kill is a command to just kill the process with the process ID we supply. For example, kill -9 equal to process ID. So to find the process ID, we could use ps minus ef and get the process ID. So maybe from other ways we could get the process ID. From the process ID, we just have to tap the process ID and kill -9 to kill the process if we want to kill the process. tar is a Linux command that is used to create the tape archives. So it is a tape, it can create a tape drive backups. It is a collection of file or directory, highly compressed archive. It is also called a tarball or tar or zzip or bzip in a Linux. So xargs versus exec. So for example, this is a find command, find dot minus name start dot jpg minus exec ls and starting braces curly braces and ending curly braces. That means in the current directory it will search for the .jpg files, and all the files it will found will be passed to this exec command, and exec command here it is ls means list. So exec run a separate instance called for each element of the output. For example, if I have a 10,000 jpg files in my current directory, that means I will create a 10,000 instances for exec command, and that would be take too much of time. On the other hand, find dot name, again this is doing the same thing. It will just print the dot jpg files and minus print 0. I mean it will just first argument it will just print the output, and then output will be passed to the xarg. Xarg combine the input into a bundle, create a bundle of it, and we run the command few times. Generally it will run one time. So that means it is very fast. So to know how much time it took, we could use this time command. Time command tells what is the real time and user CPU time and system CPU time. For example, here if I'm running time sleep 3, that means it will tell us that how much real time is used, how much user CPU time is used, and how much system CPU time is used. So because we are writing time in front of this command, it will tell how much time is consumed to run sleep3 command. Here, for example, for the above command, if you want to compare the performance of these two commands, how much time elapsed time for these two commands, we simply write time and then this find command, and then we would know that exec is slow whereas xargs is fast. Next one, lsof. It is just a list of all open files. Top is telling just CPU and memory utilization. BM stats is a virtual memory statistic. It will report all the processes, memory paging, block IO tapes, and CPU activity. All those things can be reported by BM stat command. SAR is a system activity report. Before having SAR work, you have to install sudo apt install sysstat. If you have a Fedora or CentOS or Red Hat kind of Linux, you have to use yum command, yum install sysstat, then only SAR will work. IOStat, it is just a computer system monitor tool. It is just collect and show the operating system storage input output statistics. So these are the commands for the monitoring the performance of the operating system. Next one is chmod, it is for changing the permission. mkdir is to create the directory. ps is to show the list of the files. For example, ps minus ef just showing the process IDs, and nice is setting the priority of the running commands. So cron is just a scheduler kind of thing. It has a particular syntax that first parameter whatever we provide in a cron file. Cron is a scheduler. For example, it is a system based cron also, or if you have a different users on a system, they would have their own cron. So cron is just a scheduler. Whatever the files or schedule you provide for any executable file or maybe script, that will be run as per the schedule defined in a cron file. For example, here this is an example of it. If I provided this entry in my cron file, or maybe system cron file in a Unix, so what that means, let's understand this. 30, first one is a minute, so that means 30 minutes. Hour, that means 18 hour 30 minutes. And then date of month, that means if it is the first day of month, second day of month, or third day of month, or whatever the value I provide here will tell that what day of month this command needs to be run. And then month is telling at what month this command has to be run. If I have to run it on all the months, or if I don't have a specific value, I can use a star means every month. Day of month, if I use a star over here, that means at every day of month it will run. So again, the day of week means 0 for Sunday, and then 1 for Monday, 2 for Tuesday, kind of thing. So it will run on Sunday, Tuesday, and Thursday. On 11th month, and that means on November, and these are the days, and this is the time at what time this script would be run. And very interesting to understand what is this. Greater than sign is used for a redirect, and slash deb null means it is just a null device. Whatever it is, a black hole, whatever we send it, it will be discarded. Again, here it is 2 greater than a %1. What is that? So I have given an explanation over here. That means 2 is a file descriptor for standard error. In a Unix, when you run a command, so whatever the errors are coming, it redirected to standard error, and the descriptor, file descriptor for it is 2, and slash is for redirect, a % is for file descriptor. It is telling that 1 is not considered to a name of the file. It is standard output descriptor. So 2 is a standard input descriptor, 1 is a standard input descriptor, 2 is for standard error, and 1 is for standard 2 is for standard error, 1 is for standard output. So whatever the error you have, it will be redirected to the standard output. So if I run this command, if there is some error is coming, that standard error will be redirected to the output. Finally, because whatever the output you are filling with the standard error will be redirected to the black hole. So whether you have an error, that will also go to the black hole, it will be discarded. And if you have a standard output, that will also go to the deb null. So that means when you run this command, it won't display anything whether you have an error or not. So this includes both standard error and standard output will be redirected to the black hole. It won't show anything, because this is the scheduler. If you have an error, why to display it? So you have to discard it. There is no other way. If you need a alert or you need a something paging or alert in the script, you have to definitely write a handle those alerts and send it email, or maybe create some other files so that you just read those files. Scheduler don't want to generate a output because it is a background scheduler. You don't need to display because you are not running the script manually. So this is about a cron zombie process with the parents. The processes are the orphan processes having no parent. Getty defs. Okay, it is about the login prompt settings. Simply, if you know what is a TTY, TTY is a it will tell what kind of a terminal we have to use. For example, if you use a Linux, or maybe for example Windows, you use a if you use a login prompt screen, that is just a login prompt. So it is just a terminal for us. If you using a different desktops, you have a different terminals over there. So for example, in a Linux, when you have a command line prompt, you have a one terminal, terminal 1, terminal 2, terminal 3, terminal 4. So that means you could have, because that's a multi-user operating system, you could have a different terminal over there. So these are just a login screens where you enter, where you just enter your username and password. For example, if you could have a seven terminal type in Linux, to switch between these terminals, the command is Control Alt plus F1 for first terminal, F2 for second terminal, for third terminal. One of the terminal could be your desktop, maybe Genome desktop or KDE desktop, whatever the desktop you have in your Linux. So TTY will tell what kind of a terminal you would have, and switch between the terminal is a command Control Alt plus F1 F2 plus F1 if you want to switch to the F1. If you want to switch to the F3 terminal, you just press the Control Alt and F3 in one go. CHBT is a command to change the virtual terminal type. For example, if I'm writing CHBT, that means it will take the control, the computer screen, the control to the terminal 5. And what is the Getty definitions? For example, I have some documentation over here. Init is the first process in the Linux. The parent of all processes is init. Init will read the file etc init tab, and by reading that file, whatever the written over there, it will just run those commands. So for example, it would have some Getty lines in the init tab, and that will run. And there also you would have a Getty definitions also. It will be there in a /etc/Getty def file. In that file you would have all the parameters how your terminal types would be initialized. It would have a few parameters like speed and all the attributes related to your terminal, whatever the when you start your terminal, whatever the parameters you have to set for your terminal type. Next is a BI editor. BI editor means if it is just editor to edit the files. So BI, if you say BI file1 file2, it will open both the files, and you could use EX to move across the files. And there are a few commands. When you open the file in BI editor, if you press I, it will take you to the insert mode. And if you want to use the arrow key, move up down, and then you would have a command JKHL for down, up, left or right. And if you want to save the file, you have to press the escape and :W key for a save and exit. :W is to save, :Q is to, for example, :SENU to the sequence number, and Q is for quit without saving. Next one, the files. You would have a block files, device files, and special files. One important thing is soft links. For LN is Lman. Soft link is just a shortcut, as we create a shortcut to a file. So the syntax is ln -s and original file name, and then link name. If we delete that link name, then there will be no impact on the original file. Link will be deleted. On the other hand, if we delete the file itself, the link would be of no use. It would be a dangling pointer. It would not able to open the file or recover the file. So it is just a shortcut. One more thing about a soft link. Soft link has its own inode number, and it is just a shortcut. It is just a pointer. It has no content. It is just a path or location. On the other hand, hard link, the syntax is ln, and original file name and then link name. So we can we cannot create a hard link for a directory to avoid the recursive loops. Each hard link file having the same inode number as we have for the original file name. If we delete the original file name because the hard link has the same inode number so that it can access the file again, so that means it is just we can create a number of the hard link for a file, and it is just a count, and it is just a different copies pointing to the same disk location or physical file location. Next one, there are a few more security concepts like set UID and set GID and sticky bit. These are the special bits, these are the permissions. For example, sometimes we require to set few special permissions, so we can discuss it what it is. Set UID, for example, we have a special, consider a special file for storing the password for the users in a Linux. So the file name is /user win passwd. If we just try to list the attribute of the file, that means the permission of the file is rws. S is here the set user ID bit is on. So what that means? That means when this file is being executed, the resulting process will assume that effective user ID is the of the owner class. So that means if somebody else is trying to run the command, it will assume that the file is being run by the owner of the command, owner of the file itself. On the other hand, there is a command how to set this group ID. For example, the command is chmod g+s, so that means setting the ZID for the group itself. Alternatively, you could say 2 for setting GID. So it will tell that if somebody is trying to run the file, it would have belongs to, it will assume that resulting process will assume the group ID given to the group class. So if we run the program itself, it will be assume that what would be the group of that original file, and it will run with that permissions of the group. Next one is a sticky bit. Sticky bit means this is a special permissions on the file itself. If this bit has been configured or set using this command, either we could say that +T with the chmod mode, or either we could use 1 and then permission of the file itself. Then at that moment it will prevent for any other users to delete the file. Only root or the owner of the file can delete those files if you have enabled the sticky bit. Even if the user who is using the file have the permission to delete the file, won't be able to delete it because sticky bit is on. Only the root or the owner of the file would be able to delete the file or move the file or rename the file. So this is done for very special scenario. If you want to enable all these bits in a single go, these are the command over here. As we know that set UID bit, we have the code 4, and for set GID we have 2, and for sticky bit we have 1. For example, I'm using here chmod 7 and 755. So that means it will set the UID also, it will set GID also, it will set the sticky bit also. On the other hand, if I am using 3775, that means it would have set GID and sticky bit on. You must determine it will control the permissions for the newly created files. For example, if you have a umask on the directory, for example, umask over here is w on this. So what it means, it will just take the permissions away. If you by default these permissions, whatever the default permissions on the file, it will take that umask permissions away. The same thing with the files also. If you have a umask set to w here, it will take the w, so write permissions on the files will be taken away. First of all, we have to understand what are these letters. U is for group, U is for user, G is for group, and O for others, and all. For example, this is my file, and on this file, if I want to set the permissions, for example, we are doing chmod 7755 on this file. What that means? That means the first 7 is telling that enable the set uid, that means 4, and then for gid, that is 2, and for sticky bit, that is 1. So it will enable all the bits, so that comes out to be a 7, and next one is 7 is for user itself who own the file, so that is 7, and the next 5 would be for group. So whatever the people in this group would have these permissions, so that means read and execute. So 5 is for 101, and that means read, no write, and then execute. And the next one for others, it would have 101, that means read, no write, and then execute. So in this way we could set the permissions on the file. And then umask is just telling that what kind of the permissions we have to retain, when by default what kind of the permissions to be taken away when you create the file in a directory or a file. So for example, if you have a umask set for the directory, it will whatever the files or will be created inside the directory will taken away those kind of the permissions. If it is for files, it will taken away the umask permissions from the files from the default mode. From the default permissions, it will take away those permissions. So this is very helpful when you just don't want to provide the permissions for the newly created files. The next one is sockets. Sockets is just either a domain socket or inter-process communication socket. So that is just for accessing the data between two processes on the same host. So if you have a different processes on the same host running and they want to communicate with each other, it just to take a help of inter-process communication, that calls IPC socket. Pipes is just redirection of the standard output to the some other destination. So this could be used in a scenario where you want to redirect the output from the one process and given it to the input to the another process. We could use pipes over there. Sticky bit, again, sticky bit is just setting. If that bit is enabled, that would have an impact that owner of the file or the root can only rename or delete the file. Any other user even having the access on the file won't be able to delete, rename, or move the file. So this is the work of the sticky bit. Next one is program threads. Trojan horse. What the Trojan horse does? Trojan horse can steal the user credentials, send the username and password to the hacker. What is a trapdoor? Trapdoor is a loophole that can do the illegal action, but the user is unaware of it. Logic bomb is generally a genuine. On the other hand, it is on a very special cases, it may misbehave, and that could be result in the program threat. Virus that has the ability to copy themselves, it has the power to delete the files or data, and it can crash the system also. System threats. System threats means misuse of the system resources, misuse of the network connections, and
That means OS and OS resources are under threat. So for example, worm just it is just eating the CPU resources. It could eat the RAM, it could eat the network resources, and even it will make the computer unusable, because it will eat up all the resources. Sometimes it can eat up all the RAM or CPU or even the network, and it may shut down the entire network, because network became unusable because the worm itself is eating up all the resources over there, and that's a system threat. Port scanning is just scanning the ports, and that is that is how the hacker can detect the vulnerabilities, and it could use those ports to get into the system. And denial of this service is DOS attack. That means make the system unusable. No process can access the system if that is if this is the threat. So no process can access the system. For example, DOS has attacked the browser content setting, so the browser can't be used. So this is example. So in this session we have discussed few things about a Linux operating system, Linux components, Linux commands, and few important points. If you like this video, please subscribe. Thank you very much.